So about 8 years ago, I stumbled upon a process of taking waste styrofoam that's used as packaging and running it through a canner, and which puts heat and pressure on it, and it turns it into a dense and lightweight material. Something so much so that it has multiple applications in multiple different markets. There's some samples floating around, and people are welcome to feel them and touch them, so products. When we talk about a product is based upon a material. Now, if a material has multiple uses, then there's multiple products and multiple markets that the material can be used in. End-of-life reuse. This is one of the key parts of a self-sustaining business. In our philosophy, this material, once it's reached its end of life as its product out in the market, we can take it back, reprocess it, and turn it into a whole new material that we can then sell. So imagine that one of these samples is a 4x8 sheet. The house gets torn down. What do you do with the material? Most of the time, sheetrock and outside sheeting is taken to the landfill. We can take this back, crush it up, reprocess it, and it turns into a whole bunch of small pieces that are compressed together. Once we've done that, we can then mix it with Portland cement and water and make a concrete. So far, I've been able to create a concrete that can withstand 1900 psi of strength.
Can you say that again, Duncan? I missed the number.
1900 psi of compression. So iron foam is structurally strong, it's lightweight, it's insulative. Very key point. The basis of the material comes from expanded polystyrene foam, which we all know is an insulation. I've just densified it, and the insulative properties are still in it, which allow it, in whatever form it's going to be used, whatever product, to still be insulative. I believe that the market for this material is in the building construction industry. Oh yeah, break it all you want. No, go for it. Actually breaking it. So I got $20 up here. If one of you can pull one of these screws out of the material, look like a strong guy, I'll give you 20 bucks. You're welcome to pull it, reef on it.
Can I pull it, or do I?
Yeah, go for it.
Unscrew it?
No, unscrewing isn't pulling it out.
I mean, I'm ready.
So this sample that's going around shows wood screws, wood nails, anchors that have been put into the material. I believe the building construction market would be a very good marketplace for a product made out of this material. And I'm thinking 2x6s, 2x4s, possible sheeting material. What's that?
Pull it out, it broke apart.
Oh, it broke apart. Oh, well, good. We found out some limitations. That's really good to know. So, as my business, or the business that I hope to start, progresses, I'd like to get into big box stores and even our local builder, Spinard Builders Supply. I will tell you though that in 2012, when I was in Angel, Oregon's business competition, there was a publication about my material that interested two different companies, Insulfoam and BASF. They both contacted me and said that they were very interested in the material for two different purposes. Insulfoam would like to make what's called a structural insulated panel. Now this sample is really showing the compression or the shrinkage between this is the original size that went in and this is the size that it came out, but it also shows what Insulfoam is interested in. They would like to take a panel of my material, mate it with a panel of their material, and create a 4x8 sheet out of it, and that is called a structural insulated panel. Something that's insulative and structural enough that you can actually use it as a wall panel in building construction. The same 4x8 sheet BASF is interested in replacing sheetrock with. Having interior paneling and an exterior sheeting made from this material allows for strength and insulative properties that are not inherent in construction products these days. So far, up until this time, these are my financials. I've invested personally about $13,000 into producing samples, going to business competitions, and setting up my own little LLC, as was the requirements for Angel, Oregon. My ex-mother-in-law paid $6,000 for a utility patent application, and then a friend of mine also invested $5,000 for product development and testing. So there is some so far. What I am looking for is $150,000. I'm looking for a $25,000 grant from UAA, which is a joint department grant. About a month ago, I met with Professor Scott Hamill of the Structural Engineering Department to see about having UAA do some testing. And he was pretty fascinated with the material and told me that Dr. Helena Wyszynski of UAA, who I believe is the provost, she started up a program called Innovate, which allows professors, along with a commercial entity, to apply for a grant that would allow UAA to work together on producing a marketable product. He said that he'd be willing to write a $10,000 grant that would be for this September. He also told me that if he could get another department, we could go for $25,000. So I'm looking for 5 investors willing to match $10,000 each, and that would go up against the $25,000 from the Innovate grant for $75,000. And then I know that the Department of Energy has a renewable resources grant that will dollar match. And so looking at that bit of a picture, I'd like to try and come up with that amount. What's necessary is that I create a business entity that can partner with UAA. That is key and necessary. Some of those funds will be developing a larger pressure vessel. I'm sure some of you know what a pressure canner is. Big hunk of metal that you can open up that has heat pressure inside. That's the key point in making this material. The material can be made from virgin material, or it can be made from recycled material. As in, I can go to the landfill and collect waste styrofoam, process it, and it becomes the material that can be used in one of our products. So part of the money with UAA would be to create a larger pressure vessel, which would allow for larger pieces to be tested. And ultimately, over the next 6 months, I'd like to produce a marketable product with UAA. Right now, based upon small manufacturing, this is what production financials are. It costs 24 cents to make a 2x6x8. That could be sold at $3 wholesale, $5 retail at big box stores, and I see a break even on just this one product in 3 years. My exit strategy, so getting back to the self-sustainability, my exit strategy is to move out of a leadership role within the company and take on a more research and development stance. That is paramount for this business model to work. I know my limitations. I know the strengths of other people in business, and it would be better suited for them to take over a leadership role. These are some of the other products that I've come up with. The one on the left is copper plated, which allows for conductivity of electricity across the surface of the material. I've powder coated on the center one. The right side is another sample of just how well it works as a lumber material. And then the center is just some crushed material that goes into the lightweight concrete. And I've got other supplemental data that's in here that I also have slides for if anybody has any questions or wants to know a little bit more about that information as well. But so far, this is iron foam. I'm looking for a partnership with UAA to come up with a marketable product.
Excellent. Thank you. Now it's up to you guys to ask questions and get some answers.
Yes, sir.
Great presentation. A couple questions. I'll just throw out one for the moment. It sounds like the primary market here is going to be building materials right now as you see it. What are the challenges and steps that are going to be required to get this type of product approved for use in actually using and incorporating into a house or a building in terms of the codes, the standards that would allow it to be bought and approved? If you start using for structural components, I'm assuming that there's some sort of process that's going to happen so that it can be certified or approved to be used. It'll be earthquake proof, it'll be fire resistant, all those kinds of issues. What have you learned there, and what are the challenges you face there?
What I've learned so far is that because this started out as a piece of insulation, the UL testing for that insulation is in place, which gives us not a stylist, but it gives us a starting point that we know all the testing that was done on the insulation we can do on this. That allows us to know what ASTM test we need to do on the material to find out the results. Getting into the market is going to require an early adopting set of customers that we can test the market with.
Let me ask the question differently. If I walk down right now to the municipality plan department and say, here's a house I'm going to build, and I'm going to use some 2x6 studs in the wall.
Correct.
That are made out of this material. What are the challenges for them saying, yes, that's okay? Because the testing standards you're referring to, I assume, are for an insulating function.
They are.
And now we're talking about a structural component within a wall. What are the challenges to them signing off on the building permit to say, go build it?
Well, whenever a new product is developed, ASTM, if you're not familiar, is the American Society of Testing. They, when a new material comes out and they don't have a test for it, they say, okay, all right, well, what's it similar to? And so a whole new set of tests is just kind of sort of pulled out of thin air on that material. And as long as it meets a similar criteria of lumber, then it can be approved. But as for going down to the planning community, I don't know. I don't have that answer at this time. Yes, sir.
It seems like, with your $250,000 or $150,000 financial needs out of what you thought was the potential available supply of financing, but have you matched that up with how you'd spend it yet in the near future?
I have some details on how it would get spent. Right?
Okay. Anything you can share with us?
Yeah, I need to lease a 2,500 square foot facility for 6 months. I need to build, you want specific numbers or just what it would be used for?
Yeah, I mean, it seems like most of the time when I come up with a financing need would come from the demand for that money rather than like what I think that can get.
Yes, it's based upon the demand. I need process equipment, and then it was never stated to me how UAA would disperse the $10,000 to its faculty and how long that $10,000 would last. Maybe that's only a month worth of testing. So 60,000 is a good number for 6 months worth of testing. Yes.
What's your supply for this styrofoam? And in some of the materials I was reading, it was used styrofoam, so it's kind of a recycled program. Can you describe that?
Well, yeah, it's two-part. One, we can actually purchase raw, virgin, expanded polystyrene beads and manufacture it into a product, or we can use out of the waste stream. In 2012, I was part of Earth Day in Gresham, Oregon, and on that day, Gresham told the public, bring all your waste styrofoam and we'll have it processed by Total Reclaim. And they filled up 1.5 50-foot semi-trailers just in one day of waste styrofoam that people just brought out of the community. The availability is quite extensive. Any business entity or corporation or school that buys computers you get expanded polystyrene waste foam out of that. And what is it? And they just throw it away. So it's a matter of contacting them and saying, hey, we've got a process that we can utilize that waste material. And I found a lot of schools in Oregon were more than willing to set it aside and drive a bus out, in fact, and offload it. So the availability is there. Yes, sir.
What made you go to UAA and not go on a private angle? Because you're starting to deal with a huge political quagmire. And I'm part of the university, I'm a professor there, so.
Okay.
I can tell you that going through there, you're probably gonna take more time. So why did you go there and maybe not try to do this privately, which I think time-wise, and to be honest with you, just from a mindset time, it would be better.
Well, the reason I initially went with UAA so far is just because that was the option that was presented to me by Professor Scott Hamill of structural engineering. He was the one that brought up the whole innovate that Dr. Helena Wyszynski is the one who came up with that. So I just went there with the material, said, hey guys, I know you guys are a structural lab, you got testing equipment, I need to find out some hard numbers. And then through that, so actually going privately is very difficult, in fact, because what I'm proposing is a manufacturing company, and in this day and age of angel investors and venture capitalists, manufacturing is not what people want to invest money into. Just a second, sir.
Not true. No, I'm just saying, not true. Only because
Really?
we have a fund that's already invested in the manufacturing unit here in the last month.
Oh, really? I wasn't
Yeah.
aware of this.
That's what, I guess that's our concern, is that the word's gotta get out there more, because, again, we have a fund here that has invested in, we got an engineer as part of it, we got another professor over here as part of it, myself, and others, that, could obviously help and guide, and I know Helen,
And we know Scott.
Okay, good.
And going through the university is why we didn't do it. We were outside the university.
Oh, really?
Things happen quicker, seriously, only because we know what it.
So
Do
there,
they exist on a scale that you could make an 8-foot piece of lumber?
yes,
They do.
yes they do.
Is that what you would, is that one thing is that a route you would go? If you got the funds, would you go and get one of those things and see, does this thing work to make an 8-foot piece of lumber?
I would, although they typically range from $5,000 to $20,000. I could build one using scrap equipment that's here in Anchorage that I've already identified. Originally, if I was going to do this all on my own, I would go out and buy a 500-gallon propane tank, empty it out, and turn it into an autoclave using a small boiler. And that's basically the simplicity of the machine.
And do you envision that is the end state of your production mechanism? I mean, so how do you make it so that you can churn these things out? How do you turn a sort of a big autoclave into something where you can have these things pumping off the line?
Well, I live with a systems engineer for the military, and he's got a very good idea on a machine that we put raw beads into, and they're extruded out in a little bit larger size of the 2x6, and they move into the pressure vessel through an opening in the beginning and at the end while maintaining pressure inside the chamber. So coming out is a continuous 2x6 that you typically just cut into your 8-foot, 10-foot, 12-foot lengths. And so ultimately, full manufacturing down the road, that would be the idea to go into, is to basically purchase the raw material, set the machine up, and just cut the lumber.
So, Duncan, have you considered if these pressure cookers already exist, and there are some locally? Are there some locally?
Not that I've been able to find. If I have better contacts within used equipment auctions or something similar to that, maybe manufacturing companies that some of the canning companies here in Alaska may have used older ones that could be utilized, but I haven't been able to find any thus far.
I'm just curious if somebody has one that's functional and maybe it's not used 24/7, have you considered using it, just approaching them about using it for that time?
Yes, but the issue there is that this is a new process, and people are hesitant on using their machines that are for a specific process, for my process. So they would have to have some sort of full disclosure and legal in case a chunk of this stuff got plugged up inside their machine and it had to be fixed or broken or something. So there's a little bit more to it than just going and using somebody's machine. Yes.
Yeah, with regards to like the recycled styrofoam, you know, recycling is pretty dirty. You're always gonna have paper and plastic and metal and hamburgers mixed in, whatever. How tolerant is that material to, like, say, baking in a power cord or a piece of plastic? Or
So what are you asking? Tolerant in what way?
like, if how much contamination can you have in that styrofoam and still get a safe, viable product?
Safe, 100%. The process is the exact same process used by the medical community for sterilizing medical waste. So the process itself will actually turn any other residual material with the styrofoam inert. I've actually taken waste foam that had paper glued to it, stuck it in, and when I pulled it out, everything was separated. The glue was sitting off on one side, the paper was in another, and the styrofoam was in another, and then it was just a matter of picking out the styrofoam pieces. It's kind of for the more technological, that'd be the specific gravity of all three different materials being different, and so they kind of sort of float in the water different, and so
you have to wash all your styrofoam before it goes in.
you can, or you can wash it afterwards. Typically when something that's the size of this coffee cup has a chunk of dirt on it, and all of a sudden the coffee cup is now the size of a little tiny children's teacup, that piece of dirt stays the same size and can be washed off.
A few more questions.
Sure.
So let's go off in I think a really interesting direction, which is the holy grail of being in Alaska, which is we have this little pipeline running by and we want to make more things out of it as opposed to just shipping it out of state. Is there a viable process to either out of the natural gas line or the oil pipeline to be able to produce the raw feedstock for this process competitively so that we're not having to bring styrofoam up here in order to ship it back out? And what does that look like, and is it something that could be combined with, say, the insulfoam business so that there's a conglomeration of insulation businesses here that could justify the capital investment to be able to actually have an engineered byproduct out of our pipeline? Thoughts on that?
No, but I'm definitely going to think about this more. No, well, yeah, I do have some thoughts on that, but actually the cracking process of taking that and turning it into the raw material. Benzene gas is used in the manufacture of the beads, and EPA doesn't like benzene gas. Most green communities don't like benzene gas, and so the fact that China is the one that's manufacturing this over there, and they're the one doing the benzene gas and not here, makes it helpful that in manufacturing the raw material. But it may very well be viable to use our own resources.
Anyone else?
Are you obligated to the university's input at this time, or if you got a much sweeter deal, could you let them go?
Yes, I could let the university go. I gave Scott Hamill a semi-full disclosure of the properties of the material, and he's aware of my interest in the Innovate grant competition, but there's been no hard sayings of yes, I'm going to write the grant or what. So yeah, I'm totally open to other opportunities.
You mentioned the structural panels thing. I feel like a little exploration of what else this material could be used for would be really good, because this is an incredible material. I see boat building, I see all kinds of automobile industry type substitutes, children's toys, I mean foundation work, concrete substitutes.
And that's just my one line, but this could be very handy in areas that we just don't have any idea about yet.
Yeah, that's very true. This morning on my ride in, I rode in with a Ukrainian taxi driver, and he said, 20 years doing construction in Europe. I've never seen any material like this, and it's amazing. I really like it. I wish I could attend your meeting. And whenever I happen to hold onto a piece and go walk around and just hand it randomly to someone, a new idea pops up almost immediately. And as soon as someone holds on to it, whatever their passion is, they can think of a use. Last night at the American Legion Post 28, I was talking with my friends there, showing them what I was going to be doing this morning, and one guy is an artist and he makes things out of clay. And one of the processes in running from a clay object to a metal object is lost foam casting. And he wants a chunk of this material so that he can do some modeling and see how it would work for lost foam casting. So I mean, people just come up with ideas all the time, and they look at me like, okay, run with this. Well, it's kind of hard to run with 1,000 different products and markets.
Yes, I mean, just a personal question. Working with foam, it's just like a heated wire would cut it. Does that change when it's compressed?
Yes, the resistance on the wire for cutting is a lot greater. I found that most wood tools will work very well on this, routering it, cutting it. In fact, this sample right here I cut with a handsaw last night, just a regular Stanley wood saw. And it has nice smooth edges on it. So sanding, whittling, whatever you want to do to it. One of the thoughts is that, so Insul Foam right now here in town down by the railroad, they can manufacture a 3 foot by 4 foot by 12 foot block of foam. Using the hot wire process, we can cut that into boards, put it into the pressure vessel, and out comes, after the process time, the semi-finished board. So right there is a viable option of partnering with Insul Foam.
So Duncan, we always end our time with one question to you, and that is, how can we as a community most help you in your venture?
Well, I'm looking for intense hands-on help. One of the mistakes of startups is that they make actually mistakes, and but that's only because they don't realize the mistakes that they're making. And so hands-on, intense, high executive help in manufacturing and business management would be very, very helpful. Yes, sir.
Yeah. That's amazing, the way it's done. But usually we found that all materials, they have some weakness.
Yes.
And have you searched for weakness in it, like fracture?
From just about every height that I've dropped a piece of that, it's always bounced. Maybe a small corner will chip off. I'm hoping with the testing from UAA, if that is viable, is to find out what the weaknesses are. Yes, at some point in time it will break. With the guy I'm living with, he was thinking of taking carbon fiber and carbon fiber wrapping that, so that now you've got the structural properties of being lightweight, strong, and also filled with that. So yeah, there are limitations. I don't know what all of them are. I know that sometimes I can stand on a piece of this and it'll break, but that's only because I'm 300 pounds. But
I was thinking flexibility would, or at some point having to add something like concrete, they have to add the steel to give properties of concrete by itself. So it works in a small scale, but when you build an actual useful product for use, you start finding those type of things. So, I mean, that's what I would be looking at, like, wow, that's a miracle, but it's hard for me to witness nothing else that can fail. So if you write down, like, we test the material and we come with flexibility of the bar that you apply, so over this amount, it breaks this type of, okay, this guy thought about building product and it's not built like that, so.
Yeah, finding out the limitations will definitely start knocking out some of the uses. The most viable option that I found is the concrete, and that's what I ran with at Angel Organ in 2012, because I can show video, I can show data results of hitting 1900 psi in compression, and in fact, actually, the cylinder was 6 inches in diameter and 18 inches tall, and it withstood 22,000 psi of strength. But when you get down to the psi, it was only 1900. In talking with one of the concrete companies in Portland, they said, we've got admixtures that we can add to that. We can hit your 2500 psi. We realize you're working out of the garage. You're just doing 1, 2, 3 mixtures, and you don't have the help per se. So yeah, we can hit residential concrete.
Great. Let's thank Duncan for his time this morning. Appreciate that. I encourage you to connect with Duncan himself and get those conversations going. We meet every Wednesday from 9 to 10. If you're interested in presenting your idea, go to onemillioncups.com. There's a little application process, or if you're interested in organizing or even helping us feed those presenters, we'd be glad to talk with you about that.